Hey, welcome back. So this week, NVIDIA has released and open source a brand new set of models called the Nemotron-4 models. And those models are focused on synthetic data generation. In this video, I'm going to tell you why these models are important, and I'm going to show you how you can get started with these models in NVIDIA Cloud. Now, NVIDIA Cloud is actually pretty cool, so I'm going to show you how you can use it for other models as well. So what is it that makes the Nemotron-4 models important? Well, the first thing is they are absolutely huge. They're 340 billion parameters. That's nearly 5 times the size of the Llama 3 70 billion parameter model. So it's not going to be a model that you're going to use to chat for inference. And the reason you would never use it for chat for inference is that it would be too slow, it would be too latent. We are getting used to very fast chat interfaces. And you can kind of see that here. If I just run Nemotron-4 for a second, I've asked it to write a limerick about cheese. You see it's coming back and it's pretty slow. That might have been okay maybe 2 years ago, but it's not fast enough for what we want to do today. And if I was to run the exact same query against Llama 3 running in NVIDIA Cloud, you're going to see that it's going to run much faster. And the reason it will run faster is there's less layers, and they are much smaller layers. So this ran at around 6 tokens per second, but if I just change that for a second, and now if I run the same query against Llama 3 on NVIDIA Cloud as well, you see that it runs much faster. It's got closer to 25 tokens per second. Now your results will vary, but the fact is I can run a pretty powerful model such as Llama 3 70 billion parameters and get a decent enough response rate. But if I run something like a 340 billion parameter, it's just running far, far too slow. But even then, a 70 billion parameter model is still quite a large model, and models are getting smaller and smaller all the time because we want to have that faster chat experience. Again, you can look at things like Claude 3 Sonnet, or you can look at GPT-4 Omni for good examples of why latency is really, really important there. So if I'm not going to use the 340 billion parameter Nemotron-4 instruct model for chat, what am I going to use it for? And the answer is you're going to use it for synthetic data generation. And what makes NVIDIA special here is that they've given a completely permissive license for the model outputs. That means you can take any outputs from this model and you can use it to fine-tune another model. So I could take something like the Mistral 7B base model, and I could generate synthetic data from Nemotron-4, and then I could fine-tune that model, and I'm permitted to use that. Whereas if I use something like Llama 3 or OpenAI or Claude models, then I'm not allowed to take the outputs of those models and generate my own synthetic data and fine-tune it. So if you're in the business of wanting to be able to create really neat fine-tuned models, then Nemotron-4, with its power at 340 billion parameters, becomes a really good option for generating that synthetic data. But that's not the only trick up its sleeve. It is also able to judge outputs of synthetic data generation. So I can give it the output of any chat, and it will come back with a score of whether it's correct or how verbose it is, and it will allow you to judge outputs from different models and work out which model is the best. And that is their new reward model. So in this sense, Nemotron-4 has 3 models. The base model, which is just the kind of base next token prediction model that they've got, and then 2 fine-tuned variants. One is the instruct model, which is for chat, and it's a pretty good chat model, actually. It's just too big to be able to use for inference in consumer environments, but it is great for inference for synthetic data generation. But as I said, the killer is this reward model, which allows you to judge the outputs of synthetic data generation. So really good move, NVIDIA. I think you've just made it super easy now for people to go off and create their own models. Thank you. And of course, it's in your business interest because obviously, the more people that train models are going to be using NVIDIA hardware. So it's in everybody's interest that they are able to do this. So with that, let's get started and see how we can start utilizing it. So getting started is pretty easy. You just need to go to build.nvidia.com You will need to sign up, but you can just sign in with your Google ID or something like that. It's super simple, and they will give you about 1,000 API credits to get started with as their free trial. Now, if you have a look in NVIDIA Cloud for a second, you can see it's got lots of different models available in the cloud. You've got reasoning models, so you can see that I've got Llama 3 70B instruct. That's what I ran about 2 seconds ago in that little demo. You can see it's got the mistral models, 87B. It's also got the Mistral large in there, which is pretty cool. It's got the Gemini models. It's got the new Nemotron models, which we're going to focus on in a second. And then it's got the cadastral model as well. So actually, if you saw my video on cadastral last week, that model is available. And and I can click on here, and I can write something like, and it's got a nice playground here as well. And I can write something like, write a hello world web server in Rust using the Salvo framework. And then, as you see, it's going to come back with a pretty good answer there. And again, this is probably a good example of why the Nemotron models are important, because the cadastral model here, although it generates absolutely fabulous code, and this really is good code for Rust, you can't use the outputs of the cadastral model in any commercial sense. So you can't use it for commercial work, and you certainly can't use it to fine-tune or train another model. But with the Nemotron models, you absolutely can. So as I say, this is a pretty good interface. You can explore, play around with the different models. It's got a little chat playground. They've got some really interesting vision models as well. So you see Getty Images, and then they've got Shutterstock's 3D models there. So if we go into Getty Images, for example, that's a pretty good picture. But let's try something like unicorn with rainbow colored hair. And there we go. Here's a picture of some unicorns there. This one looks more like a horse with a wig on it. These are looking a little bit more unicorny, so nice job there. So you can play with the image generation models. They've got vision models for kind of descriptions as well. So you see the lava models, and you can see the Microsoft 5.3 vision models as well, Polygemma. So if you want to be able to do stuff like describe this image, then those models are part of it. They've got some RAG models in there as well, such as BGE, even some speech models as well. So it's a pretty good kind of playground. So with that being said, we're going to just code something up. So to do that, I am going to need an API key. So we're going to start with the Nemotron instruct model, i.e. their chat model, and then we'll just ask it a few questions. Now, I want to get an API key, so I just need to click on this Get API Key button there. I can click Generate Key, and then it will generate me a new key. And then I can copy that, and then we are good to go. So now that I've got my key, I can come back into my editor. I'm going to create a new directory. We'll call it Nemotron -record. We'll just cd in there, and then we will create ourselves a .env file. So we'll just code.in here, open up Visual Studio Code. And then this is the interesting part. The astute amongst you will notice I am typing in OpenAI API _key, and then I'm just going to paste that in here. So yes, as you can guess, everything that runs on NVIDIA Cloud, they have this thing called NIM, which is NVIDIA Inference Microservices, and they are completely compatible with OpenAI client libraries. So they're a server-side protocol. Their JSON responses are the exact same as OpenAI's ChatGPT responses. And that means you can just use the OpenAI libraries. You don't need to worry about any other SDKs. So hence why I'm putting in OpenAI API key here. By the way, for those folks who are thinking about stealing my key, I will obviously generate a new key at the end of this as well. So now that I've got that, I will just install .env, because we're going to do that to load my environment variables there. And now that I've got .env installed, I'm also going to pip install OpenAI as well. And therefore, we are now up to date. We've got the client libraries that we need. So now to get started, all I'm going to do is I'm going to create a file called infer.py, and we can start coding up our application. So I'm going to import .env, and I'm going to import OpenAI as well. So we'll just do from OpenAI, import OpenAI. And then I think to make this a little bit more fun, we will just then import our parse as well. So I can just pass in a prompt as we go along. And then all we're going to do now is have a little function that will read the -- prompt argument from our command line, parse the arguments, and then return the prompt. So when we call get prompt, it's just going to essentially utilize whatever got passed in to the command line. And then we're just going to load our environment variables here. So now that I've done that, I just need to create my OpenAI client. So it's just going to be client OpenAI. And then I'm going to set my base URL. And this is the key thing. It needs to be not OpenAI's base URL. It needs to be NVIDIA Cloud, their NIM services. So I am going to call HTTPS. It's going to be integrate.api.nvidia.com. And I'm going to /v1 there. If you need to know where the API is, again, you can always go into the playground and you can just use the playground to get the API URL. Next thing I need to do is set the model name. So I'm just going to set the model name is going to, now in this case, I'm obviously going to set it to NVIDIA Nemotron-4 340B-instruct. And that is the model name. Now, if I want to interact with any other models, such as Llama 3 or etc., and I'll do some demos of that in a second, I can just change the model name here and then we're good to go. Now I want to get the prompt. So I'm just going to say prompt is equal to get prompt, which is the little function I created 2 seconds ago. And now I need to set up my completion. So I'm just going to say completion is equal to client.chat.completions.create. And then all I need to do is set the model is equal to the model name. I'm now going to set the messages is equal to, and again, it's following the OpenAI kind of standard here for chat. So I'm just going to put in role, and it's going to be, in this particular case, a user message. And then I just need to set the content, and that is going to be equal to whatever the prompt is. And now I can set a temperature. So again, there's lots of different defaults here. I'm just going to set the temperature is equal to 0.2. Temperature determines how creative it's going to be. I'm going to set top P is equal to 0.7. And then I'm going to set max tokens equal to 1024. Just in case you are wondering, the max context length for the Nemotron-4 is essentially 4K. So it's not a massive context window there. And then finally, I'm going to stream out my results. So we'll set that to true. And now all I need to do is actually stream out the results. So I'm just going to say for chunk in completion. And then we will say if chunk.choices. And we're going to look at the first choice only. And we'll look at delta.content is not none. So we're just looking at the chunks that come back, and then I'm just going to print it out. So that is now good. So if I run python infer.py, and then we pass in the prompt, and we will use my favorite, who is Ada Lovelace. And there we go. We're now interacting with a 340 billion parameter Nemotron-4 model. And you can see it's quite slow, right? You see it coming back. It's a good answer. Ada Lovelace, born Ada Byron in 1815. I'm streaming out the results, but of course it's taking quite a bit of time because it's a 340 billion parameter model. As I said, we can interact with different models there. So if we change that, although we're focusing on Nemotron for this video, we can put in other models in here. And as I said, they've got some pretty cool models in there. So if I just set this to Meta Llama 3 70B, and we want the instruct model, please note that it's slightly different from the Hugging Face model name. So normally it's Meta AI, but in this case it's just Meta here. And again, if I run this, same question, who is Ada Lovelace? You see 70 billion parameter model, much smaller. It's coming back much faster there. And again, if I want to, I can talk to other ones. So I can run this maybe against the 8 billion parameter model. Let's just clear this, run it again, and this is going to be even faster because it's a much smaller model. You see the speed. And that's the difference of layers, right? So the larger the number of layers, the more layers they are, and the more dense those layers are, the slower the model's going to be, which is why the 340 billion parameters model is probably too big for real chat inference but it's really good for data generation. And as you said there, that Who is Ada Lovelace that came from Nemotron, I could use that to fine tune my own model, whereas I can't do that with the Llama models. Again, if I want to play with other models as well, I can just change this to something like Mistral AI, and I can put in Mistral Large, and then we can just run this again, and we can find out Mistral's point of view on who Ada Lovelace is there. Again, much smaller kind of response. There are other models in there as well, so there's things like the Snowflake Arctic model. Let's run that. There you go, super fast coming back there. Of course, it's got code models as well, so if I wanted to, I could maybe put in Mistral AI Cadastral 22 billion parameter instruct model. Again, I did a video on this recently. So in this case, we can ask Cadastral to write something like a Fibonacci function using recursion, and then of course it's going to come back with a pretty good answer there. And that's not the only code model as well. I could use the Google Code Gemma, which of course you can use the outputs for. And again, it's going to write a recursive function there as well using Fibonacci. That works pretty well. And of course, the IBM Granite 34B code instruct model, which again, you can also use the outputs for in your coding. And as you see, it comes back with the Fibonacci. So as you can see there, NVIDIA Cloud and the NIM services are really good. Even if you're not using the Nemotron model, it is just really nice, really fast cloud. So again, something to kind of mess around with, and there's a good set of models. But we are focused on the Nemotron models, and the ability to run a 340 billion parameter model is just insane. The fact that I can ask a query such as who is Ada Lovelace, and I can actually use the outputs of the model to fine tune and train my own model is just insane. And again, this is why they're focused on synthetic data generation. And actually, some of the outputs are absolutely insane. So if I write something like write a limerick about Patrick Mahomes, you can see there's a quarterback named Patrick Mahomes whose skills in the field are quite known. With a rocket arm and a smile so bright, he's a sight to behold in the stadium's light. In Kansas City, he's made his home. I mean, it's not the best limerick in the world, but it is following the kind of structure. And again, we can have other ones like kind of Taylor Swift in here. And this one's great. There was once a singer named Taylor whose music could never be graver. She wrote of love and loss with a voice that's a boss, and her fans, they just couldn't behave better. That is actually a really good limerick. So again, and it's not just limericks and things like that. You can do stuff like write a song. Let's write a song about Ava Lovelace in the style of Snoop Dogg from Ava's perspective. Let's see what comes back. Yo, it's your girl Ava Lovelace. I'm here to make some noise in a world of tech. I'm the one who brings the joy. So you see what I mean? If you are wanting to train a model on different styles, whether it's limericks, whether it's songs, it's obviously at 340 billion parameters. It's got great world knowledge. This is just game-changing for fine-tuning models, especially when you start to combine it with something like the RAG pattern and being able to then have kind of a teacher model where you can generate different variations. It's just insane. However, so far we've only looked at the instruct model, which, as I said, pretty good for chat. It's just too slow for powering a chat inference layer, but great for synthetic data generation. Let's now look at the reward model and how that changes things. Okay, so to do that, almost all of the code remains the same. The only thing I need to do is change this from being -instruct, and I'm going to set that to being -reward. So that now gives me the ability to chat to the reward model. And then the next thing I need to be able to do is pass in the messages. So I'm going to ignore this get prompt. And I want to take the messages here, and I need to provide the user message and the assistant response, and it will then judge that. So let me show you what I mean here. So I'm just going to get rid of this messages piece here, and I'm going to set this to messages. And now I'm going to set my role as user, and I'm going to set the content here is who is Ada Lovelace. which is our example from earlier. And I'm going to sort of maybe give a couple of good and a couple of terrible answers. So we will now give the assistant response. So I'm going to say role is equal to assistant, and we'll just put this on the line below. And then I just need to give it some content. So we will give it some pretty bad responses to begin with. So we'll say Ada Lovelace is the world's first programmer. That's not bad, right? But it's not as detailed as the other ones. And again, I will just put some quotes around here. And then finally, the reward model doesn't support all of the kind of stream and the temperature and all the max tokens. So I'm just going to get rid of that. And now I can just toggle this lot out here, and we will just print the completion. So let's run that. And now you can see it's came back with some answers. So you see chat completion, it's given an ID, it's given us some choices. And then down here, you're going to see some stuff that's pretty interesting. So you see message, chat completion message, content helpfulness. So it tells me how helpful the response is. So it's 2.28. Correctness is 2.39. Coherence is 3.625. That's pretty good. You can see it's kind of low complexity. I gave a one sentence answer, and then it's giving me low in verbosity, right? So it's judging me on how helpful the response is, how correct it is, how coherent it is, how complex the response is, and how the verbose it is. So if you think in something like GPT-4, which is quite a verbose model, you would imagine that's going to have a quite high verbose scoring on that. So if you're trying to tune a model where it's got really short, sharp responses, that verbosity is really going to help you out there. Again, combined with complexity. But again, it can pick up complete errors. So if I say Ada Lovelace is the world's first acrobat, and we will just run this one more time. You can see now the correctness and the helpfulness is all just went down. It's a very coherent answer. Again, it's negative complexity. It's not verbose, but it's just wrong. So this is a great model for doing judging of responses. So if I'm training my model, I can just take the outputs. Maybe I'm pulling outputs from different models. Maybe I'm pulling it from Nemotron itself. And then when I get a good response, I can check it against this model and see how correct it is, because Nemotron's using its 340 billion parameter knowledge base to tell you how good that answer is. And then it's also judging you on the other stuff. So here I'm going to replace my messages, and I'm going to put in the response from the Gemma model. You see it's a much longer response. It tells you all about Ada Lovelace. If I just save that, we'll just clear it and run it again. Now you're seeing very coherent answer, 3.8. Very correct answer, so it's got a much higher scoring. Very helpful answer. So the Gemma model, great job. Not very complex, and a little bit verbose at 2. And now I'll just paste in another one. This time it's a response from GPT-4o. And remember, GPT-4o is a lot better than GPT-4 used to be for kind of verbosity. But let's run and see what the results are going to be. And we can take a look at there. Very helpful answer, very correct answer, very coherent, low in complexity, which is good. Not bad in verbosity, very similar to kind of how Gemma is. But you could imagine that if we had run that against something like older GPT-4, that could be really, really kind of bad there. And this one here is the output from the Claude 3.5 Sonnet, so the new model that was released by Anthropic. And we can run that against here, and then just run our reward model one more time. And there we go, very helpful, 3.7, correct, 3.59, slightly less correct than GPT-4o there, coherent, very, 3.95, very coherent model there. Complexity is low, verbosity, so it's less verbose than GPT-4o. So you can imagine the fun that you can actually have with that. It's a very accurate model and a very useful model, but being able to judge the outputs from different models on coherency, verbosity, and being able to fine tune in to the style and model that you want is absolutely insanely brilliant. And then if you're fine tuning your own data, not only can you use Nemotron as something to generate outputs, but if you are training synthetic data, whether it's something you've manually created, or maybe you're using another permissive model like Mistral 7B, or any other model that allows you to use the outputs, you could actually use the Nemotron model, the reward model, as a judge of the outputs. Or you can combine it with the Nemotron instruct model, which is going to generate the outputs, and then you can judge how good that is. So if you want to try different variations of prompts, then you would be able to do that and then pick the one that's got the best and then fine tune with your answers there. And again, it will help you deal with hallucinations. So if you're answering a question or generating some synthetic data and it's wrong, it's just going to come back and tell you it's incorrect, right? So again, really useful. So these two models, the instruct model for generating synthetic data and the reward model for telling you how good the response is, I think is really game changing for kind of fine tuning models and benchmarking what you do. So really nice job, NVIDIA. And then of course, their new NVIDIA cloud and these NIM microservices are brilliant. And one of the things I love about the NIM microservices is if I take something like a third-party model like Llama 3, I can actually just package it up and then run it on my own hardware. Now, we as regular people don't have that level of hardware on the machine, so it's not going to work. But if you're an enterprise, that kind of makes sense. You can run on their cloud, or you can package it up or run it on your own private cloud. So I kind of love what they're doing there. So great job, NVIDIA. Wonderful cloud, really fast on the inference, and really great new Nemotron models for both instruction and rewarding. Now, the final thing that I was going to say, which I think is really interesting, is they talked in the paper on how they created their instruct and their reward models. And guess what they actually did? They used the Nemotron base model to actually generate all the fine-tuned data sets for the instruct model and the reward model, which is really cool. And actually at the back of the technical report, they give a couple of the examples of how they generated those prompts. And I think it was something like 10,000 generated kind of prompts that they use. So if I just bring that up for a second and we skip down to the very bottom of the paper, it gives you an example of the prompts that they were using. So again, if you're fine tuning your own models, this is a really useful thing to look in their paper. You see kind of prompt generate macro topics. So what they actually did there is they used the model to generate topics. And then once they got the topics, they then pumped the topics through and had another prompt for generating subtopics. They did the same for kind of math there. And then they would do the same for things like classifying, generating Python topics. And then they're just iterating. So once they've got a topic, they would then generate Q&A questions based on the topics. Then they would revise the answers. Then they would do the same for writing styles. So they were just literally using the Nemotron base model to then even generate the instruct data set and the reward model itself. So I think really interesting techniques. So also it's worth checking out their paper, because I think if you're interested in fine-tuning models, then it's a really nice thing. And again, there's a lot of base models out there, so just using the same techniques as they've did and the same types of prompts, and you could generate your own fine-tuned models as well. So anyway, hope you've enjoyed this video. Hope you've seen the sort of value of the Nemotron model. So even though it's a huge model that's probably too big to run on your local machine, actually using NVIDIA Cloud and using the paper techniques and using the reward model, you could start to generate your own fine-tuned data set. And maybe in a future video, I will have a go at generating our own fine-tuned data set and training that and see what that looks like as well. But hope you've enjoyed the video. I really love what NVIDIA's done with Nemotron, and I really love what they're doing with their NVIDIA Cloud as well. And I hope this was useful, and I'll catch you on the next video.